Hello, everyone. Today, I have something completely new, something super exciting, and as you can see, even my eyes are smiling right now. So, my name is Prince, and I'm a machine learning research engineer at RCAI. I develop a lot of interesting new, models and architectures, and even some optimizations on machine learning. And on my free time, I'm the Apple MLX king, so I contribute to open source, in particular, the Apple ecosystem. So today we're going to talk about VLMs. How many of you have an idea of what a VLM is? Anyone? No one knows what a VLM is? Only you? Come on. Okay, so today I'm going to go, explain everything that you need to know about VLMs. I'm going to talk about some of the challenges of on-device deployments, and I'm going to actually give you guys a demo of one of my, of a project I built with one of my most famous open source project called MLX VLM. And I'm going to show you some of the coolest community projects I've seen so far. So, who am I and why am I here? Do I have the credentials? Well, as you can see, this is some of the contributions I've had over the years. I've contributed to many projects, including Neptune AI, where I used to work, and more recently at MLX, and also contributed to PyTorch and many other projects. In the last 12 months, I went on an adventure of my life. This was unbelievable. If you had told me in the beginning of the year that I would have made this many contributions, I would have told you that you probably are crazy. But I'm super excited to share that I've contributed over 900 models, open source models, to the Hugging Face platform, as well as all of these models combined have over 100,000 downloads. There's one model uploaded a couple of days ago, the Llama 3.370B. That one is already close to 100K on its own. That single model there. I have over 20,000 likes across all of those models and projects. And pretty much if you look at the list of the top 10 models in MLX, most of them are pretty much models that I contributed. So let's talk about VLMs, so vision language models. What are they? How do they work? And how can you get started today? So if you can look at this graph here, there's a small image, but the idea is a vision language model is a model that takes an image as well as text as input and outputs some text. This could be a classification of what an object is in an image. This could be a caption of the image. This could be anything you can think of that a computer vision model can do, vision language can do, and much better. So how do they work? This is the architecture of Polygemma. Polygemma 2 was released recently, and I added support into MLX. And the basic architecture that you can see is you have a image encoder. This could be your clip model for those of you who are familiar with clip, but there's another vision encoder called SIGLIP, created by Google. It's much better in terms of performance. So you have a vision encoder that takes in your image, transforms that image into the feature space, and then you have a projection. This could be simple linear layers. This could be, multi-layer perceptrons and etc. Different models have different kind of structures, but usually you will see either a linear projection or cross-attention. And then what this does is that it projects whatever vision features you have into the language space. And then you can use a large language model. This could be Gemma 2, Llama, etc., to then generate answers to your question using the vision features as well as your query. So in a nutshell, here are some of the tasks that you can see. Usually, vision language models can do multiple tasks. So a single model is capable of doing object detection, pointing, captioning, and segmentation, and so on. And one of the most interesting ones that I really like, although it gave me a lot of headache, is Florence 2. So Florence 2, as you can see here, is a model that uses a different architecture from most. It has an encoder-decoder language model, and as well as has a normal vision encoder. This is your SIGLIP. But this particular architecture allows it to be, one, super fast, Two, it's capable of doing multiple modalities really well. Like it's pretty great at, for example, if you look at some of the queries there, it's detecting either the person or detecting the car and the person or segmenting the person on its own. So this model is capable of doing all of that. And on top of this, it's really great with OCR. And I will show you in a minute how good this model is with OCR. All right. But before we go into actually seeing these models working in the wild, we have to talk about some of the challenges of deploying any machine learning model on device. There are a couple of, of course, there's a long list of caveats and problems that you can come to, but the main ones that I see are model size, latency, resources, and quality. So let's talk about model size. If you take, let's say, a 72 billion parameter model, even with your best NVIDIA 4090 or even an A100, you wouldn't be able to run that model in full precision easily. Even if it was quantized, you would still struggle because you would need to, one, be able to build the machine to use your NVIDIA GPU, which is expensive. The NVIDIA graphics itself is expensive. But there is a different way that we are going to address this with MLX. But model size has always been a concern. You can't run big models like Llama 405 70B on device, but that has changed. Then there's latency. Because of the size of these models, they tend to be slow. Even if you manage to squeeze a 32 billion parameter model into an NVIDIA graphics, it's going to be slow. Then there are resources. Of course, you have your NVIDIA GPU, but you have your CPU, RAM, and etc., which are not cheap. So you have to really account for that lack that you have. And then there's quality and performance trade-offs. So you can think about, well, if I quantize this model, how much performance am I losing on my task compared to actually running this model in full precision on the cloud? So you might think, well, Prince, what challenges really? I can just get a A100, H100. I got money. But unfortunately, I'm here to help you. Actually, fortunately, I'm here to help you reconsider your thought process. So you have on the first side an A100. It has 80 gigabytes of VRAM, and it costs 84,000 zlotys. Just the card. You don't have the machine, you don't have the GPU, the CPU, RAM, etc. Just the card. Then in the middle, you have a maxed out Mac Mini with 64 gigabytes of unified RAM, M4 Pro, and that costs a small fraction. You could buy probably a cluster of Mac Minis before you buy a single NVIDIA GPU, A100 in particular. And then you have kind of a better alternative if you're running this at home, which is to get the Mac Studio. A maxed out Mac Studio has 192 gigabytes of unified RAM, and it costs still, you could still buy like two Mac Studios compared to like a A100. And I'll show you why this is important. And then you might say, well, I have a 4090. How does that compare? You would have around 24 gigabytes of VRAM, whilst with a Mac Mini, you still have way more RAM at your disposal. And it's at the same price as the 4090, you have a complete machine that runs everything. You don't have to buy anything. You don't have to go look around for things that match or don't match. Well, a maxed out Mac Mini or Mac Studio might be all you need, but they are still expensive machines. And let me kind of show you why you can make that investment and why you should actually trust me and the community behind MLX and Mac Studios. MLX VLM, a project that I developed earlier this year when I started contributing. MLX is actually about a year old and a few days today. It was released late last year. When it started, I downloaded it and I tried it out. And I was like, well, Olam is still better. But I didn't give up. I thought this has a lot of potential. And being a team at Apple actually developing this we can have really crazy improvements. This is when I thought, okay, I'm going to develop MLX and help develop the ecosystem inside MLX. So the first project on my own that I built was MLX VLM. So what is MLX VLM? It's a package for running inference and fine-tuning of vision language models on device. So this runs completely on your MacBook, or Mac Studio, etc. Even potentially in the future, your iPhone or your iPad. So let's talk about fine-tuning. Okay, there's no video. Okay, there's a video. So this is me fine-tuning Pixtral, 12 billion parameters, completely on device. My machine is a bit more resourceful. It has like 96 gigabytes of VRAM, but I can fine-tune Pixtral and models even bigger completely on device using QLoRa. And it doesn't even get to like 90% usage of my resources. And soon we will have like more options like full fine-tuning, LoRa, and other types like DPO and etc. What happened? Okay. All right. So let me change it manually then. Object detection. So MLX VLM has a lot of models now that can do really accurate on-device object detection. And they can run at like 100 tokens per second plus. That is faster than most of your hosted models in the cloud. And you have your images or sensitive data completely private to you. This is one use case where at the top you see a quantized model. Full precision performs better, so this is a quantized model, but it got most of the items correctly, except this speaker here. It kind of thought it was reversed. But it got really, really close. And then we have another one here. This is the first polygemma, and it completely detected all the animals in this picture. Then you have object pointing. This is a really interesting one. This was developed by Alan AI. This is the model called Momo, and it's pretty good at pointing at objects. And I will show you why this is important in a minute. So here you can see that I asked at the top to point to all the people. It detected not only me and a couple of people here up front, but it also detected this person right here. This is pretty accurate, and it's running completely offline. So that's pretty great. And then someone challenged me to detect all the posts in this image. It's a foggy day. It was a foggy day, so you can see that it actually almost, accurately detected most of the posts with some hallucination, but like it really got correctly. And this is like a 4-bit quantized model. Imagine what the full precision model, what you could do with the full precision model. Well, and you also have OCR. And I think there is a person here that developed a project called Sparrow that I will share more in a bit, that he can actually run this OCR on multiple documents completely on device using MLX VLM. Here you have this image of this function here, and we pretty much completely did the OCR accurately, no characters left behind. And this is why I talked about Florence too. So Florence 2 is pretty good at doing multiple things, and one of those things is OCR with bounding boxes, or as they called it, OCR with regions. Here we have a menu, and I don't think you can see, but inside the menu, if you look at these boxes, it has the actual OCR, like the text that it detected within the box itself. So it got most of it accurately, except probably this mug here. But this, again, is another quantized model. If it was like full precision, which you can run at like 400 tokens per second, you can get better performance. Then you also have OCR with structured outputs. So if you have documents, you might want to preserve the structure of the documents or extract information from those documents in a particular structure. So MLX VLM allows you to do that. You can just define the schema in JSON that you want or XML, and then the model is going to actually extract all of the data from the image into that format that you want. Then comes computer use. I bet most of you saw Anthropic's computer use demo, and that very same day when I saw it, I went to the shower and I thought, I could actually do that on device. I think it's possible. We have all the models we need to do this. We just need to kind of tweak a few things and add a few new models, especially to MLX. And it started this obsession of mine about a month or two ago where I wanted to create computer use that runs completely local. So what is computer use? Computer use is just the ability of having your machine learning models control your machine, whether it's keyboard clicks or mouse clicks or even particular commands like using your bash shell to execute something for you. It will be like the Jarvis of computers. So you could say, hey, open X and do this for me, or post this image, and it's going to go ahead and like execute the task for you. But the problem with Anthropic's kind of approach, they use Docker containers. The setup is so complicated. I understand. They're a company. They have to look for risks in security, all these things. But the thing that bothered me the most was the model is running in the cloud. It's taking screenshots of my computer, my information, my private sensitive data, and it's taking it away. Is there a way of us bringing that back? So that's where I started thinking about this, and I went on this research adventure during my free time. And I came across a particular structure. So we have two types of GUI agents, or GUI agents. The first one is level 1. It takes a screenshot of your screen, right? It runs some low-level instruction like click here, do this, do that, but it's usually single-turn instruction. You're only giving it a particular task. And then that agent is going to output the particular action, or you can think about it as function calling, and you're going to execute that action, and then it's going to render the result on your machine. But then there's a next level, which is autonomous GUI agents. These agents, on top of doing the normal single-turn instructions, they can actually achieve particular goals. So if you want them to go ahead and change a particular line of code on your GitHub or even locally on your machine, they are able to execute that. So for that, they require memory, planning, reasoning, and a few more other components to make it achieve your goals. I'm excited today to present you at least one of those versions. So let me show you a demo. Hopefully this goes right. All right, so I'm running it here locally. I'm not sure you'll be able to see it because I guess you have to see the actions. But let me just go to X first. Let's start with, I have a notification. Let's start with opening that notification. Well, I want to make it a bit more complex. Let me start with the most advanced use case I have. And then if that doesn't work, we'll come back to this manual one. I require absolute silence. Shh. Open notifications. It takes a second to run. Ooh, wow. Because of the mic, it actually heard the wrong thing. Sorry, let me put the mic down. Open notifications. Wow, it has a lot of interference here. So I will post the video about this. It was actually working yesterday correctly. But yeah, I'll post a video about this. Let's go to the manual use case. So the one where we can actually run and use text instead of voice. But yesterday I had the most craziest experience with this particular use case. So let's say click on notifications. Okay, the screen size changed. Give me a second. Okay, so because it does affect the way the model perceives the screen. So if I put here, click notifications. Hopefully that works now. Oh, God, really? One more time. Hopefully this is the lucky charm. Click on home at least. Come on. Yeah, probably that's interfering with the setup, but don't worry. I will like show you guys how this looks like. Let me put and I think it detected correctly because it tells me what it's doing. So here's an example, and I have like saved a lot of screenshots, and I also have like a navigation history where you can see particular commands that I gave. Here's one image. You can see here the red dot. So this was click on explore. This was click on notifications, and you can see that it's actually pretty accurate at like clicking items in the screen. There are a bit more complex ones like click on this particular post, and it works. But for some reason, because I have two different screens, it's extended. It should be something different. But anyways, let's leave it at that. I will just post something. And you can see pretty much even if I ask it to open all the new posts, it correctly detected that, okay, the new posts are here on X, and pretty much click there. I asked it to enter Google in the search box, so it detected the search box correctly. I asked it to click on this BMW video yesterday using voice, and it worked amazingly, and it opened the video. Today, just probably because of the setup, is a bit hard. And again, notifications, it gets it all the time, so it doesn't fail. Let's see the latest ones, what happened. Oh, it was looking at the it was looking at the current screen. That's why it didn't work. I should find a way to switch, but I wouldn't be able. Can I do that? I would have to find a way to switch the screens for it to work.
Just duplicate screen.
Duplicate? So which one? Mirror? Building?
Mirror.
Mirroring, the thing is, I have to have an extra screen, so stop mirroring. Let me try and see main display. Okay, so probably, okay, I made this one the main display. So let's try again. I need to send this. Yeah. Okay, here we go. Hopefully it works now. Click on notifications. Let's see. There you go. It works. We can try one more just to, say that it's not a fluke. So click on home. So you can actually go to home, and there you go. So it actually works pretty accurately. It's running around 100 tokens per second, completely on device. It's really good to log your data. So this was a quick demo. The voice also works, but probably there's a lot of interference here, and I won't be demoing that part, but I will make a video about it. Well, let's go back. So So what I just showed you is basically the GUI agent. It's able to do a single task when you ask it. It can click on stuff, it can run particular shortcuts, it can select text and do a few more things. There's a long list of actions. It can even scroll the page. But I was talking to my team yesterday and I said, well, I think we can do all of this completely on device if we make another more powerful model. This one only has 2 billion parameters. That's why it can run so fast. But imagine if it was a 7 billion parameter model that could do planning, reasoning, and all these things, including the actions themselves. You would be able to have a true local copilot that sees everything you see and can help you do things without sending your data anywhere. And all of this is powered with MLX VLM. It's about 200 lines of code, including some boilerplate, like all the functions and etc. But the actual core thing that makes it work is less than 10 lines of code. I only need to like put the functions and everything else so that it can actually act based on a particular use case. So it's not working anymore. Okay. So what are some of the optimizations that we have been doing on MLX VLM? In particular, me and a few people, like one person from Apple, one of the core maintainers of MLX. We've been working towards optimizing it, and we have some really interesting results to share. So some of the best practices that I found to be very useful, and there are recurrent issues, GitHub issues that I get. It's like, well, my machine is overflowing memory. Well, you're trying to process a 4K image on a machine that doesn't even have like 16 gigabytes of VRAM. So the first thing that I would say is like, resize your images. You don't need 4K for it to work. Actually, none of the resolutions I just showed you is working in 4K. It's probably like 1080p, about 1080p or a little bit more. If you have a larger model that you want to use, let's say 7 or 10 billion parameters plus, I would recommend for you to resize all of your images. You only need about 900, 800, sometimes even 500 by 500 works. Then you have to experiment with different models and quantization levels because each use case is different. This actually goes to the final point, which is you need to test your models on your use case. So first, start by resizing images. Take your use case. Let's say you want to do text processing or OCR. Find out a list of models that are the best at that. Test them out. Find out what works, what quantization, whether it's 8-bit, 3-bit, 4-bit, 6-bit, or even if it works in bfloat 16. If you have a Mac Studio maxed out, you probably can run almost everything out there. So just test out and find out which one works for your use case. And here's one that I'm actually super excited. So I ported Qwen to Vision to MLX, and I got some optimizations from Anui he works at Apple, and he said, "Hey Prince, you should change." I think it was like 2-3 lines of code from NumPy to MLX to core MLX, and that unlocked more than 64% speed up on M2 Ultra. So it went from like 50 tokens per second to about almost 100 tokens per second with a simple change that was there. And then that same change measured on my M3 Max, I noted about 20 to 30% increase in speed up, especially for like 4-bit quantizations. And this didn't affect performance, like the actual performance of the model in terms of accuracy. It only improved the speed. Now, let's talk about, so those were just some of the optimizations. There are many others. I would recommend you follow us on GitHub, give us a star, and look at the PRs there or even GitHub issues. There are lots of optimizations all the time. And I'm on a weekly schedule on this, so every single week there's probably either a new build or a PR fixing some of the issues or adding new features. And then some of the really cool use cases I've seen from the community that I'm super proud to share here today. So the first one is by ENG. He is the developer of Sparrow, and he's running Qwen2 72 billion parameters in 4-bit on a maxed out Mac Mini. That is unheard of. This is unbelievable, and it runs at decent speeds, more than 10 tokens per second. Not 10, I think 8 to 10 tokens per second. And you can see here, he has a really cool post. It went viral, so you can check it out. And this is a state-of-the-art model, like the best of the best, running on a Mac Mini. Then there is Matthew. He built a Minecraft agent using MLX VLM and FastMLX that can actually see. So you can the text here is actually describing the scene here. It's probably too small and I cannot see it from here, but it's actually just describing the scene, and it's using Lava 1.6. And this is running completely on device. You can build such agents to play games with you or whatever you think is interesting. But games is a really good application. Then you have this one by N8 Programs. He built an app that can solve triple integrals in 30 seconds. So just by selecting the integral, the model can see that, extract the text, and solve it using a math language model, and can actually speak the answer. The actual post has the video. I didn't put the video here, but it runs in about 30 seconds, the entire pipeline. All right, so some of the conclusions. I know it's a bit verbose, but think about it this way. Using MLX VLM or running MLX models on a Mac, you're spending about 100 to 200 to 300 watts in terms of energy consumption, compared to double that if you're running an NVIDIA GPU, either A100, 4090, 3090, and etc. And you can run bigger models and faster models faster using a Mac. Second one, MLX VLM pretty much unlocks a new level of multimodal on-device accessibility features. You can build native apps that run using MLX VLM, and they can preserve the privacy of your customer, first of all. Second, you have almost zero costs because you don't have to think about infrastructure. The target device is the infrastructure. So all of the cost is incurred by the user and not necessarily by you. And of course, you get privacy as a bonus. On top of privacy, there's also latency and so many other benefits of running a native app. Addition to that, like just parallel to that, there are use cases, new use cases like computer use that get me excited and get the community excited. And since new models are coming every day, either by RCAI where I work and many other companies, you can actually transform these models into MLX and run them on your machine. And the greatest use case that I found this year was computer use. I'm super excited, and I cannot wait for version 2, where we have like completely autonomous pipelines. Probably early next year. I'll be working on this during Christmas and etc. And finally, we have a growing community. It's amazing, and I'm so thankful for the incredible community that has grown around MLX, and in particular MLX VLM. A lot of people are contributing, finding bugs, sharing their feedback, and that for me is an amazing thing. Right now, we just crossed probably, I think, around 50,000 downloads, which is a milestone for me. This is by far my most successful project, and I'm super excited to see what you guys build with it. Thank you.
Thank you, Prince. Maybe a short round of questions if anybody wants to ask something.
I've got a question about models. You are using quantized versions of models, right? But you said that bigger ones can also run. So are we still limited by those 64 gigabytes of URAM on the device, or is it able to unload and... Oh.
Sorry, can you speak louder?
Oh yeah, I guess I was too far from the micro. So you've been using quantized versions of models, but you also mentioned that you can use the bigger ones on the device, right?
Yes.
What's the limit of the model size we could use? Can we exceed the URAM size and just load some layers or something like this, or are we still?
There is a formula to calculate this. It's usually the bus speed, like the transport bandwidth speed of the device, plus the device resources like URAM and etc. And there's actually a calculator by my friend Ray Fernando. He has an online calculator for MLX models that you can just put the amount of URAM you have, and it can tell you what is the biggest model you can run at what quantization level. So there is a formula to this. Actually, you can even ask Claude and he will give it to you. Just put your Mac Mini or MacBook's structure and ask it to find out what that result is.
Okay, thanks.
Yeah.
A second question, maybe last one.
Okay, thank you. I have a question. When you showed that model, when it was autonomous, you said to click something. Mm-hmm. Is it possible to tell him to make more complicated moves, like consisted from multiple steps? Like, for example, not just click notification and after that you tell another thing, but you tell one thing and he does multiple actions.
Exactly. So that's a really great question. That is the autonomous GUI agent that I'm going to work on with some of my colleagues. Yesterday, I just showed my team this demo, and they were like, "We should actually build something like that." So I cannot wait to like get into it and build our first version of this, and then share it with the world. It is possible. You just need a lot of synthetic data, GPUs, and pretty much experience to build that agent out. It should be able to do everything.